Converting recurrent fractions into decimals. This is a very special part of this tutorial, because at the first sight a recurrent decimal seems impossible to convert into a fraction due to its infinity of decimal places, so the conversion of a recurring decimal into a fraction is impossible through the usual methods. Therefore, a completely new approach must be used for this kind of conversion. Let's begin to explain this new method through an example where a one-digit recurring decimal is involved. For example, let's consider the number 1.3333, or 1.3, a recurring decimal obtained when dividing 4 by 3. The method we will explain here consists of in the following steps. Step 1, we denote the original number by n, i.e. we have the following shown on screen. Step 2, we multiply the original number by a factor that gives a new number with the same decimal part as the original. Here, this factor is 10. Thus, we have the following shown on screen. Step 3, we subtract the original number from the new one to eliminate the recurring part, i.e. we have the following shown on screen. The same thing is done with the factors containing the figure n. Thus, we have the following shown on screen. In this way, we obtain the equation shown in the following on screen. Step 4, now, we solve the previous equation and simplify the result is needed. Thus, we have the following shown on screen. This is the number we were referring to at the beginning of this explanation. Let's consider a few other examples with other types of recurrence. Example 1. Write the following recurring decimals shown on screen as fractions. Solution 1. A. We have the following shown on screen. B. This time we have to multiply the original number by 100 to obtain again the same recurrence. Thus, we have the following on screen. C. This time we have to multiply the original number by 1000 to obtain again the same recurrence. Thus, we have the following shown on screen. Both numerator and denominator are divisible by 9. Check this by using the divisibility rules explained in tutorial 1.6. Hence, we obtain the following shown on screen. Again, we see that both numbers are still divisible by 3, so we obtain the following shown on screen. Sometimes the recurrence does not begin immediately after the decimal point, but more on the right. In such cases, we first multiply the original number by a factor that leaves only the recurrence after the decimal point and then, we multiply this number by another suitable factor that gives the same recurrence, in order to make possible the elimination of recurrence through subtraction. Example 2. Write the following recurring decimals shown on screen as fractions. Solution 2. A. We have the following shown on screen. B. We have the following shown on screen. C. We have the following shown on screen. A special case in this process is when the recurring part contains only nines. In this case, we obtain not a fraction but a whole number as a result. Let's consider a couple of examples to clarify this point. Example 3. Express the following recurring decimals shown on screen as finite numbers. Solution 3. A. We have the following shown on screen. B. We have the following shown on screen. That is all for lesson 3.5.4 and the end of chapter 3. To continue this mathematics topic, please watch 4, Ratio and Proportion. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.